Hello everyone, myself Mrs. Prachi Kale from Department of Mechanical Engineering, VPKBIT Baramati. Today we are going to see velocity analysis of simple mechanism using ICR method. Types of instantaneous center of rotation. There are three main types of instantaneous center of rotation. First, fixed instantaneous center. So their position and location is fixed for any configuration of the mechanism. Second is permanent instantaneous center. Their position is not fixed but locations is fixed. They move as mechanism moves. And third is neither fixed nor permanent instantaneous centers. Their position and location vary with the configuration of mechanism. In first case, in fixed instantaneous centers, these are fixed at the point. Like suppose an ICR is located at any fixed link, then the location of that ICR will be fixed and its position in space is also fixed. So if the mechanism moves, then also this fixed instantaneous center will not move. In second case, for permanent instantaneous center, its position is not fixed but its location is fixed. It means if it is located at the intersection of the two links, then whatever may be the position of the mechanism, this ICR will always remain at the intersection of the link. But as the mechanism is moving or the links is moving, that position in space will change. And third one is neither fixed nor permanent instantaneous center. So their position and location vary as the configuration of the mechanism varies. So we will see it in detail that which are these fixed centers, which are these permanent centers and which are these neither fixed and nor permanent centers when we will locate these on a mechanism. The first two types of the ICR, that is fixed ICR and permanent ICR, can be located by observation. But the third type of the ICR, that is neither fixed nor permanent type of ICR, will not be possible to locate using the observation method. So it needs to use the Kennedy's theorem of the ICR to locate this neither fixed and nor permanent types of the ICR. So we will see it in detail when we will locate the ICR of the mechanism. So let us consider one example. A mechanism as shown in figure has the following dimensions: OA equal to 200 mm, AB equal to 1.5 meter, BC equal to 600 mm, CD equal to 500 mm and BE equal to 400 mm. Locate all possible ICRs by inspection. If crank OA rotate uniformly at 400 rpm clockwise, find velocity of B, C and D and angular velocities of link AB, BC and CD. So this is a problem statement. So using ICR method, we can find only linear velocity and angular velocity. We cannot find acceleration by using ICR method. So this method is specifically used when you want to find out the velocity of the link. So we'll see now how to find out these velocities, that is linear velocities of the points and angular velocities of these links. Step number 1. To find total number of links and to give numbers to the link. So for this, first we need to draw the configuration diagram. So we will take a scale, say 1 centimeter equal to 50 mm. So you can take any suitable scale as per the space availability, but while drawing the mechanism diagram, take care that this mechanism diagram will draw at the center of the page, because we need to extend these links and to get the intersections of that lines to locate the ICR. So draw this mechanism diagram or configuration diagram at the center of the page, and there should be enough space above and below and on the both sides to extend these links. So this is the basic requirement of drawing the configuration diagram. Now with the scale and the given dimensions, draw the configuration diagram. So after drawing the configuration diagram, we have to find out the total number of links and we have to give the numbers to the link. So while giving the numbers, we have to follow that whatever the fixed link in a mechanism, we should give link number 1. So always link number 1 will be the fixed link. So how many fixed links are there in the mechanism? To all we will consider at number 1. So this E is also number 1. And the slider is sliding on the fixed link, that is also link number 1. So once we give number 1 to the fixed link, then as per the sequence of the motion transmission, we will give numbers to the links. So this is link number 2, this is link number 3, this is link number 4, link number 5 and link number 6 is the slider. So total number of links is equal to 6. Then step number 2, to find total number of ICRs and to list them. So we have to find out the total number of ICRs. So say let n be the number of links. So we have n is equal to 6. So the formula to find total number of ICR, that is n, capital N is the number of ICR and small n is the number of links, is equal to n into n minus 1 upon 2. So substitute n equal to 6 over here and solve this, it will give n is equal to 15. So total number of ICRs is equal to 15. Now we have to list all these ICRs. So we have to prepare this table. So say take links 1 to 6 and here we have to locate the ICR. So how to write these ICRs? So now consider link number 1. So link number 1 with link number 2, it will give ICR 1, 2. ICR of link 1 with 3 is I1, 3. ICR of link number 1 with 4 will give I1, 4. ICR of link number 1 with 5 will give I1, 5. And ICR of link number 1 with 6 will give I1, 6. Likewise, we take link number 2. So we have to take ICR of link number 2 with link number 3. Because ICR of 2 with respect to 1, that is I21, is same as I12, which we have taken already. So we will not take link 1 now. We will take the next link, 2, 3. So I23, 24, 25 and 26. Then we will take I3, 4. We will not take 3, 2. Because 3, 2 and 2, 3 is same which we have taken already. So 3, 4, 3, 5 and 3, 6. Then I4, 5, 4, 6. I5, 6. And as 6 number is the last number of link, so there will not be any ICR for this link number 6 as we have taken these ICRs already, that is 5, 6, 4, 6, 3, 6, 2, 6 and 1, 6 we have taken for link number 6 already. So these are total 15 ICRs. So this we have to locate. Now out of these I1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 1, 4 and 1, 6. These are the ICRs which can be located by observation. So these are fixed and permanent ICR. And these remaining 1, 3, 2, 4, 3, 5, 4, 6, 2, 5, 3, 6, 2, 6 and 1, 5. So these are neither fixed nor permanent kind of ICR which need to be located by using Kennedy's theorem. So we will see now where is the location of this fixed and permanent ICR. So here now this is the mechanism diagram which we have drawn earlier. So here when a link is fixed at one end, then its center of rotation will be at the fixed position. So this is I12. So now see, this I12 is a fixed type of ICR because whatever may be the position of the mechanism. So say this angle 30 degree will go to 40 degree, then 50 degree, then 60 degree likewise. Then whatever may be the positions of these various links or the configuration of the mechanism, the I12 will not change. So it will be always at this point O. As this O point is fixed, so its position and location in the mechanism is fixed. So this is called as a fixed type of the ICR. But now here link number 2 and 3 intersect at point A. So ICR of this two link is at location A, that is I23. So if two links are moving with respect to each other, then their ICR is located at the intersection of the link. So I23 is at point A. Now here you can see the location, that is I23, is always at the intersection of link number 2 and 3. But so that is fixed, the location is fixed, but its position in space will change as this angle 30 degree changes to 40 degree, changes to 50 degree and so on. So this I23 will move in the space. but it will always at the intersection of link number 2 and 3. So this is called as a permanent ICR. So I12 is a fixed ICR, I23 is a permanent ICR. Likewise, at point B there is I34. At the intersection of link number 3 and 4 there is I34. So this is also permanent ICR. Now I45. At the intersection of link 4 and 5 this is I45. And I56 is at this point. At the intersection of link number 5 with link number 6, that is the slider. And then ICR of the slider with respect to fixed link, that is I16, is at infinity. Now here all these links have turning motion, so they have instantaneous center of rotation. But for the slider it is a reciprocating motion or linear motion. So in this case, to locate its ICR, we assume that the slider is having the linear motion. So the motion of the slider is a part of a circle of infinite radius. So we know that if a circle is having infinite radius, then a part of its curve is considered as a straight line. So with this we say that the ICR of this slider, which is rotating on a circle having the center at infinity. So the radius is at infinity. So that's why the center is at infinity. So the ICR I16 is at infinity. So remember, for a slider, ICR of a slider with respect to a link on which it is sliding always perpendicular to the motion of the slider at infinity. So here slider is moving horizontal. So perpendicular to the motion of the slider, that is vertical, at infinity there lies I16. If slider is moving vertically, then you have to draw a horizontal line, and on that horizontal line mention that the ICR at infinity. So likewise, ICR of a slider is perpendicular to motion of the slider at infinity. And then it is I14 over here. ICR of this link number 4 with respect to this link number 1, which is fixed because this is pivoted. This link is pivoted at point E. So ICR of link number 4 with respect to link number 1 is located at point E. So likewise, we have located these ICRs by observation. So all these are fixed and permanent ICR, out of which I12 and I14 is fixed, and 2, 3, 3, 4, 4, 5, 5, 6, these are permanent ICR. As well as 16 is also permanent ICR, because as slider will move, this line will move. So now this is the method to find the ICR by using observation. Now step number 4, to locate ICR by Kennedy's theorem. Now Kennedy's theorem states that if there are 3 links which have relative motion with respect to each other, then their ICR are located along a straight line. It means if there is link number 2, 3 and 4 which have relative motion with respect to each other, then their ICR, that is I23, I34 and I24, must lie along a straight line. This is called a Kennedy's theorem. So now we will see how to use Kennedy's theorem to locate moving ICR. Now for this, first draw a circle of any radius. You can take any radius and you can draw it anywhere on this page. Just draw a circle at any radius. Then on this circle, take points equal to number of links. So we have number of links is equal to 6. So take these points equal to number of links. So we have taken 6 points. So you can take these points anywhere on the circumference of a circle. It is not that what should be the distance between the 2 consecutive points. Just randomly take these points anywhere on the circumference of the circle. Then whatever the ICRs we have located, say I have located I12. So join 1, 2. So this is link 1 and link 2, and this line represents ICR I12. Then I23. So this is ICR I23. Then I34. This is ICR I34. Then I45. So this ICR I45. Then this is I56, I16 and I14. So all these lines represents the ICRs which we have located already by observation. Now say you have to locate I13. I13 we have to locate. Now we have to consider that we have to find two triangles for which I13 or this side 13 is a common. Say triangle 1, 2, 3 and triangle 1, 4, 3. Now what is the logic behind this? That if these are three links, link number 1, 2 and 3, then their ICR must be along the same line, and for link number 1, 4 and 3, their ICR must also be along the same line. So now what we will do? We will say I13 is a common side for triangle 1, 2, 3 and triangle 1, 3, 4. So I13 will have two sides 1, 2, 2, 3. So these are the sides of the triangle 1, 2, 2, 3. And the second triangle is 1, 3, 4. So these are the sides I14, 3, 4. So here you can say that I13 is common for this triangle 1, 2, 2, 3, 1, 3 and 1, 4, 3, 4, 1, 3. So like this we have to write this. Now join 1, 2 and 2, 3. So here is 1, 2, here is 2, 3. Draw a line and 1, 4, 3, 4. So here is 1, 4, here is 3, 4. So draw a line joining 1, 4, 3, 4. Now these two lines intersect at a point over here. So this is my I13. So here we can see 1, 2, 2, 3, 1, 3 along a straight line. These 1, 3, 1, 2, 2, 3. These are along a straight line. And 1, 3, 1, 4, 3, 4 are also along a straight line. So this satisfies the Kennedys theorem. So like this we have to locate this I13 which is a moving ICR. So its position and location is not fixed in a space. Now second, say I have to locate I15. Now the similar procedure, we have to search for two triangles for which 1, 5 is a common side. Say 1, 6, 5 is one triangle and 1, 4, 5 is another triangle for which 1, 5 is a common side. So we will write for 1, 5, 1, 6, 5, 6. So these are the two sides of the triangle 1, 5 and 5, 6. And second is 1, 4, 4, 5. 1, 4, 4, 5. So now we have to join 1, 6, 5, 6. So 1, 6 is this line and 5, 6 over here. So that will be the same line. And 1, 4, 4, 5. So 1, 4 and 4, 5. So this is 1, 4, 4, 5. Extend this. We have to get the intersection of this line with this vertical line. So this is the location of I15. Okay. Like this we have located I15. Now say I have to locate I24. Now again for I24 I have to get two triangles for which 2, 4 is a common side. So I'll say 2, 3, 3, 4 and 1, 2, 1, 4. So for I24 it is I12, 1, 4. 1, 2 and 1, 4. And I23, 3, 4. 2, 3, 3, 4. Now here is I12 and here is I14. So just join it. So this is a line for I12, 1, 4 and 2, 3, 3, 4. So this is the line for 2, 3, 3, 4. So this intersect at this point. So this is I24. So in this way we have located I24. Here you can search for any other triangle combination. Whatever the triangles are available you can take. You can have different combinations of the triangle. But the location of ICR will remain same. Now next is say I have to locate I25. So to locate I25 you can take 1, 2, 1, 5. 1, 2, 1, 5. So here now see you can use this dotted line now. Because you have located this ICR 1, 5. So you have this ICR already. So you can take it as a one side of the triangle. And second triangle is I24, 4, 5. 2, 4, 4, 5. Here also we have taken this dotted line. So now where is I12 is over here and 15 is over here. So join this 2 4 4 5. So this is 2 4 and this is 4 5. So join this. So these two lines intersect at this point. So at this point there is I25. So in this way we can locate all these ICRs, remaining ICRs, say 3 5 we can locate, or you can locate any other remaining ICR by using this Kennedy's theorem. Now if in case you want to take intersection of I16 with say I12, suppose you are taking a triangle of, say you have to locate I26, suppose you have to locate I26, then you will take triangle 1 2 6 and the two sides for I26 will be 1 2 and 1 6. So 1 2 is over here and 1 6 is this line. Now how to take the intersection? So in this case simply shift this line over here, I12. Okay, if in case you have to take the intersection of a point and ICR of a slider, in that case shift this ICR of a slider which is at infinity to this point. So directly this line you will shift it parallelly over here. So here you will draw a vertical line. That will be the intersection of I12 and I16. And then you can search for another triangle for the two sides and then you will take the intersection and you can locate the ICR. So this is the procedure to locate the moving ICR. Now if in question it is mentioned that locate all ICRs, in that case you need to locate the remaining ICRs. But otherwise if it is not mentioned locate all ICRs by Kennedy's theorem, then you can find out the ICRs, those which are required to find the unknown things. So only that ICRs are enough if it is not mentioned to locate all the ICRs. So this is the procedure to locate the ICR by Kennedy's theorem. Now we'll see how to find angular velocity of link AB. That is omega 3 we have to find. Now n is given 400 rpm. From this you can find omega equal to 2 pi n by 60 and that will be equal to omega 2. Now we get to take the ratio of omega 3 upon omega 2. So in this way here you can take the ratio of any two angular velocities. Like here you have to take omega 3 upon omega 2. You can take omega 4 upon omega 2, omega 5 upon omega 2 likewise. Now here how to write this ratio? So say omega 3 upon omega 2 is equal to, now the common ICR for link number 2 and 3 is I23. So here I23, I23 you will write on both the sides, numerator and denominator. Then ICR of link number 2 with respect to fixed link, you have to write it over here, I12. And ICR of 3 with respect to fixed link, that is I13, you have to write over here, I13. So omega 3 upon omega 2 is equal to, this is the distance between I12, 23 upon I13, 23. Now here I12, 23. So just look at over here, 1, 2, 2, 3. So measure distance between 1, 2 and 2, 3. With the scale, measure this distance. And measure I23 and 1, 3. Measure this distance between I23 and 1, 3. And substitute those distances over here. No need to consider scale as we are taking the ratio. And substitute omega 2 equal to 41.887 and solve this, it will give you omega 3. That is equal to 10.216 radian per second after solving this. Similarly, we have to find angular velocity of link BC. That is omega 4 we have to find. Now how to find omega 4? Again you have to write the equation omega 4 upon omega 2. So how it will be? Omega 4 upon omega 2 is equal to, common ICR is 2 4. So on both sides write 2 4 2 4. I24 I24. I12 will be in numerator and I14 will be in denominator. Now measure the distance between point I12 and 24, substitute over here. Measure the distance between I14 and 24, substitute over here. Substitute omega 2 and calculate, it will give you omega 4. That is equal to 27.924. Now next is to find angular velocity of link CD, that is omega 5. Now again write the equation omega 5 upon omega 2 is equal to I25 on both the sides. I12 will be in numerator, I15 will be in denominator. Then measure the distance between I12 25 divided by distance between I15 25. So don't take the scale over here as we are taking the ratio. So you will get the actual velocity of omega 5, that is equal to 7.309 radian per second. Now when you will calculate this, you will not get exact these values, but you may have some error because of the scale which you are taking. The scale may be different or because of some graphical error. So plus minus 2 radian per second variation is allowed for these values. Now next is to find velocity of point B, C and D. Now again how to write this equation. So velocity of point B. So B point is on link number 3. So actually B point is on link number 3 also and B point is on link number 4 also. So if you consider B point on link number 3, take it here omega 3 into ICR of link number 3 with respect to fixed link, that is I13 and B, distance between point B and I13 into omega 3. If you consider this point on link number 4, then it will be omega 4 into I14 and B, that is distance between B and I14. So you can use any of the formula because B point is common to link number 3 also and link number 4 also. But here I have taken it is on link number 3. Now we have already calculated omega 3 previously. Substitute that omega 3. Then measure the distance of point B from I13. Now here you need to multiply by scale. When you will measure the distance of point B from I13, multiply it by scale. Take a note of this. In this case you need to multiply it by scale into omega 3 will give you the actual value of velocity of point B, that is 12565.689 mm per second. Same way point C. So C point is also on link number 4 and is also on link number 5. You can take it on link number 4. So it will be velocity of C is equal to omega 4 into distance of C from I14. And substitute these values to get the velocity of point C. Remember, multiply this distance, that is distance of C from I14 into scale. Same way you have to find velocity of point D. So consider D lies on link number 5. So as D is on link number 5, measure the distance of D from I15 into omega 5. See, remember here always you have taken D is on link number 5, so ICR of 5 with respect to fixed link, that is 1. You have to take I15. Here also C is on link number 4, so you have to take ICR of link number 4 with respect to fixed link, that is I14. Here B is on link number 3, that's why you have taken I13. So likewise you can write the formula for any point by considering on which link that point lies. Now substitute this omega 5 and calculate this. Here also you have to measure the distance between point D and I15 and multiply it by scale. And then you will get the velocity of point D equal to 3142.87 mm per second. In this way, by using ICR method, you can find linear velocity of any point and angular velocity of any link in a mechanism. You can write your own formula by considering the ratio of angular velocity and by considering the point on which link it is lying. Likewise, this is the method to find out velocity by using ICR method. Thank you.